Hey guys, welcome back. We'll continue with Python crash course, and today we'll cover lists. We'll learn what lists are, how we can access elements of a list, how we can organize lists, and how we can add, remove, or make changes to a list. So let's jump right into it. So lists are one of Python's most powerful features that are available right out of the box. Lists are basically a collection of items in a particular order. So for example, we can have letters in a list, or digits, or strings, or for example variables that we are working with. In order to define a list, we basically write a bracket, an opening bracket and a closing bracket, and inside of that we will have the different values that are separated by commas. So let's take a look at an example and let's switch over to Sublime Text. We can create a new file and call it chapter 3, for example. And inside of that file we can define a new variable, which is going to be a list. So in order to create a list, we use the bracket notation, and inside of that we can, for example, have multiple different strings that are the elements of the list that we are working with. And it's important that the order here is fixed. So basically the order is really important to reference the elements. Let's first of all just print out our list. So here if we print bicycle, we basically get back all the values of the list here. But typically we want to reference elements of the list. To do that, we simply take the name of the list, we add brackets after it, and then we add a number to refer to the index. So for example, if we print out bicycle 0, we can see we get the first value track back. And the reason for that is that the values inside of our list are indexed, and the index starts at 0. So instead of saying this is the first element, the second element, the third element, the fourth element, we actually start counting from 0. So this is the 0th element, this is the first element, the second element, the third element. That means bicycle 0 refers to track. And if we change that to bicycle 1, for instance, it's gonna refer to the second entry here. And in a similar way, we can refer to redline, or for example to specialized, which is going to be the third entry here. Now we can combine this with the fact that we can do some operations on strings, which we learned about last time. So we can take bicycle 0, for example, which is track, and then we can call the title method on it, which of course capitalizes the first letter of our word here, and we see it has been changed accordingly. So we can combine those different concepts. So instead of referring to values of the list from the front, we can instead also reference values at the end of the list. To do that, we would instead write bicycle -1, for example, which is going to return the last entry of the list. So instead of counting from the first item 0, 1, 2, 3, we can start from the back and say -1, -2, -3, -4. That means -4 should actually give us back the first value track. Especially if we have a very long list, that can be very handy to work with. Now, when we are working with such a list, we may want to print out some text or do some operations with some of the values in the list. And to do that, we can define a new variable, and inside of that we can use an f string to print out a string, but also refer to items in our list. So we can say my first bicycle was A, and then we refer to our list here, bicycle. And we can index, for example, the first value here and use the title method to capitalize that properly. Now, once we define that variable, we can then print it out. So now we can see my first bicycle was track. And of course we can adjust that here if we want to, for example, reference the third value here, redline. We would simply update that, print it again, and then it's updated accordingly. Now at this point, let's take a look at some exercises. We can actually try this ourselves. So first of all, we can start with the first exercise and store the names of a few of our friends in a list called names, and then print each person's name by accessing each element in the list one at a time. So let's do that. Let's say we have a list of names of different friends. We can simply type them out, and of course we need to separate all values by a comma. Now if we want to print the entire list, we simply print out names. So we use the print statement and we pass names to it, then we get the list back. But what we actually want to do is we want to print out each name individually. So here in this case we would use the index, print names 0, print names 1, and print names 2. And now we see we get back Bob, Peter, and Lisa. And instead of, for example, referring to Lisa with index 2, we could also write -1, of course, and that's gonna refer to the last item in the list, so it's gonna give us back the same value. Now the next exercise, let's build on top of that. And what we should do, instead of just printing each person's name, we should print a message to them. And the text of each message should be the same, but each message should be personalized with a person's name. So to do that, we can remove the print statements here. And instead what we're going to do is the following. We can use an f string, and we can refer to the entry in the list and then add our text here. So inside of the curly braces we use names, and then for example we can select the first entry, which is going to be Bob. So now we print "Hello Bob, how are you?" But of course we can greet our other friends as well. So here let's just add that 2 more times, and then we can reference the second and the third element by using index 1 and index 2. And now we are greeting all our friends here in that list. So finally, let's take a look at the third exercise here. Here we should create our own list, and we should have a list of our favorite mode of transportation, and then print out a series of statements such as "I would like to own a Honda motorcycle." So let's do that. We could, for example, say we have a list of cars here, and there could be multiple entries in there here: BMW, Tesla, and for example Honda in here. And then we can print out a statement and say, "I would like to own a car." So here we can refer to cars 0, for example. And actually we don't need car here, so let me just remove that. "I would like to own a BMW." We can do the same for the other values. So here we are going to refer to cars 1, which is the second element in the list, and cars 2, which is the third element. So now we print out those statements, the statement here 3 times, but every time we update the value here. Now so far we have been accessing elements of our list. Of course we can also make changes to the elements in our list. We can change the elements themselves and exchange them with other values. We can add elements to our list, and we can also remove elements from our list. So if we head over to Sublime Text again, let's say we have a list here of different motorcycles. So we can have different values in there, different brands, for example Honda, Yamaha, and Suzuki. And of course we can initially just print that out. So we're gonna get back our list of motorcycle brands here. Now if we want to change any of those values, we can do that easily. So we would simply go ahead and take our list name again, motorcycle. And just as we saw before, we can access elements through the index. So we can, for example, access the first element Honda here by typing motorcycles 0. But now we can update a value by using the equal sign and setting that to a different value. And now if we print motorcycles again, we will see that now we replaced Honda with Ducati. So that's a very easy way how we can exchange those values and make updates to the elements of our list. We can also add elements to our list. And there are different ways of doing that. We can, for example, append elements to the end of our list if we want to add an additional motorcycle, for example. So let's go back to the original motorcycles list that we have here with those 3 different entries. And now if we want to add a new value to it, instead of replacing one of those values, we would take motorcycles, our list, and call append on it, which is a method. And then we can pass the name of the value that we want to add to the end of the list. So for example, Ducati. And after that we can print our list of motorcycles one more time. And now we can see, if we compare the value before we added it and the value after we used append, we can see that Ducati has been added to the end of the list. So the append method makes it easy to build lists dynamically. So for example, we may start with an empty list and then subsequently we can add additional values to it. So let's, for instance, comment this out, and let's say we have an empty list of motorcycles to start with, like this. We could then start with that empty list and then call append on it to add the different values. So for example, we can add Honda, then after that we can add Yamaha, and finally we can add Suzuki. Now if we print that out, we will basically get back our original list, but this time we added those values dynamically. So we started with an empty list and then we added those values one at a time. And this is an approach we will typically take. It's very common because often we don't know which kind of values we're gonna have. If we think about the case that we collect input from a user, for example, let's say in a game or in an application, then we don't know which values will be provided. So we start off with an empty list, and then as the user enters input, for example, we can append that and add that to our list to work with. So append is one way of how we can add a value to the end of our list. If we want to add an element to a different position of our list, then we can use the insert method. So the insert method allows us to add a value to any position of our list. If we go back to our motorcycles list here, for example, let's say we want to add a new value to the very beginning of the list instead of the end. Then we, instead of using append, we would use insert. We would need to add the index where we want to add the value, for example 0, to add it at the very beginning, and then a comma, and then after that we add the values that we want to add. And now if we take a look at motorcycles, we can see that we now added Ducati at the very beginning of our list. And of course we don't have to add that at the very beginning, we could add it at a later position. So if we add 1, for example, we will add it as a second entry here, so after Honda. So if we run that again, we can see we now inserted Ducati at the second position at index 1, so 0, 1 in here, and that's how we can add elements. So insert allows us to choose where we actually want to add an element to. Now when we work with lists, of course, we may also want to remove some elements from our list. So for example, if we play a game, let's say a shooter game, and we have some aliens in there and we shoot an alien down, then we want to remove it from the list of enemies, of active aliens that still exists. Or if we have, let's say, a web application and a user cancels their account, for example, we may want to remove that user from the list of active users. So that would be an example of how we can, or when we want to remove elements from a list. And again, there are multiple ways of doing that. If we go back to our original list of motorcycles, if we want to delete an entry here, an easy way to do that is to use del followed by the name of the list and then the position where we want to remove an entry from. So here, for example, we have the motorcycles list and we are using the del method. We're passing the zeros entry of motorcycles, so Honda, to it, so that will be removed from our motorcycles list. So now if we print motorcycles one more time, we can see that initially, of course, we have all 3 entries here, which we are printing out. Then we are removing the entry at index 0, so the first entry here. And then we get back, when we print this out again, Yamaha and Suzuki, so Honda has been removed from our list. Of course, we can also remove entries from other positions. So let's say we want to remove Yamaha from the list. Then we would simply update that and say del motorcycle at position 1. And that's going to remove Yamaha from the list. So we still have Honda and Suzuki still remaining in that list. If instead, when we remove an entry, we want to do something with that entry. So for example, if we remove, let's say, Suzuki from the list, we want to print that out. Then instead of using del, we would use the pop method in Python. So the pop method removes the last item in a list, but it lets us work with the item after removing it. So an example is the following. We can take our motorcycles list, and then we can create a new variable, popped motorcycle like this, and then we take our motorcycles list here and we call pop on it. So pop is a method that will always remove the last entry here, for example Suzuki. So if we print motorcycles one more time, we can see that we now have the last item removed, but we can now also reference the return value. So here we are removing the last entry from motorcycles, and the outputs that we get from this, we store that in popped motorcycles. So if we print that out, we can see Suzuki, the value we removed, is actually stored in the new variable here, popped motorcycle, so we can work with that. So it's a handy way if you want to store the value, if you want to remove it, and then, for example, print it out to users. So if we have our list of motorcycles here and we stored the values in the chronological order in which we owned them, we could use this to use the pop method to remove the last entry and then write out a statement that this was the last motorcycle we owned. So to do that, we would say last motorcycle, that's our variable, and we receive the last value here by calling pop on the motorcycles list, and then we could simply add a print statement using an f string stating the last motorcycle I owned was a, and then of course we need to reference last motorcycle, and we could, for example, call the title method on it to make it look a little bit nicer. So if we run that now, we can see the last motorcycle I owned was a Suzuki, which is the last entry in our list. So that's one way of using the pop method to very easily reference an item there. The pop method is, however, quite powerful. We can use it to remove the last entry as we saw here, but we can really remove any position, any element from any position from our list. So if, for example, we don't want to print out the last motorcycle we owned, but let's say the first motorcycle, we can do that, and we would simply pass an argument to our pop method here. For example, if we want to have the first entry, we would call pop and we pass 0 to it, which is the index of the first element. So let's update that here, and let's say we want to print out the first motorcycle. Let's adjust our text. And now we see the first motorcycle I owned was a Honda, which is indeed the first value in here. And of course we can reference any other position. If we want to reference Yamaha, we could simply pass 1 to it, and then Yamaha will be returned here. So pop is quite flexible in that way. Now we learned already about 2 different ways of removing values from our list using the particular, so either del or pop. But sometimes we want to remove an item not by their position in the list, but based on their value. So let's say we have a list of items here, for example those 4 motorcycle brands. We can print out those motorcycles, and then we can say we want to remove an entry, but this time we don't want to remove it based on the position, but instead we're going to use the remove method, which allows us to actually pass a value to it, and then we're going to remove that particular value from our list. So now if we print motorcycle, our list again, we can see that we actually removed Ducati, and we removed that based on the value in our list. So as a practical example, we could say, for example, we have a variable called too expensive, which is equal to Ducati. And then we can go ahead and say we want to remove an entry here that's too expensive, so we can use our variable here like this. So we would remove that, and then we can print out a statement and say here using an f string we can refer to too expensive, which is equal to Ducati is too expensive for me. So we print that out. and then we basically remove that. So if we take a look now at our motorcycles list, we see it has indeed been removed from our list here. One important aspect to note here is that the remove method deletes only the first occurrence of the value. So let's say, for example, we are removing Ducati, but we have it in our list twice. Maybe we have two different Ducati motorcycles. And now if we call remove on it, we can see that the first entry of Ducati has been removed, but the second entry here still exists. So that's important to note. We will later on learn a concept of how we can loop through the list of items and how we can remove multiple entries that have the same value. So let's take a look at some exercises regarding that concept. So the first exercise here is to have a guest list. So if we could invite anyone living or deceased to dinner, who would we invite? We should create a list that includes at least 3 people that we'd like to invite for dinner, and then we use our list to print a message to each person inviting them for dinner. So let's do that. We can have a new list here called guest list, and let's add some values in here. So for example, Albert Einstein, Elon Musk, and maybe Jeff Bezos. And now we can go ahead and use an f-string to print out a message. We can refer guest list, for example, the first entry, like this. You're invited for dinner. Let's print this out. So we are inviting Albert Einstein here, and we can report, or we can actually do that again for the value at index 1 and the value at index 2. So now we wrote an invitation for all 3 of our guests that we stored in the guest list up here. So next we want to change our guest list. So we had just heard that one of our guests can't make it to dinner, so we need to send out a new set of invitations, and we can start with the program that we wrote so far. We need to add a print call at the end of our program stating the name of the guest who can't make it. So let's say, for example, Elon Musk is too busy. So we can say, we are using an f-string here, and we say guest list position 1. Cannot make it, unfortunately. So now we printed that out. Next we modify our list to replace the name of the guest who can't make it with the name of a new person that we are inviting. So now we can go ahead and say we want to replace the value at position 1 of our guest list, so 0, 1. So here we type guest list at index 1, and we can replace that with, for example, Thomas Edison, like this. And then finally print a second set of invitation messages, one for each person who is still in your list. So now we can basically just take what we already wrote up there and print that out again. But now if we run our program, we can see that Elon Musk cannot make it, unfortunately. So that's the message up here. And then we have a new set of invitations. We are still inviting Albert Einstein and Jeff Bezos, but now we replaced Elon Musk with Thomas Edison. And for the next exercise here, we found a bigger dinner table. So now we have more space available. So we can think of 3 more guests to invite to dinner. And we can start with the program we wrote so far. We can add a print statement to the end of our program, informing people that we found a bigger dinner table. So let's start with that. Let's add a print statement here. Found a bigger dinner table, like this. And then next we can use insert, the insert method we learned about, to add a new guest at the beginning of our list. Then use insert to add a new guest to the middle of our list. And then we use append, which again can just add a value at the very end of the list to add one new guest to the end of the list. So let's do that. Let's take our guest list here. And we're going to use the insert method first we need to provide the index. So if we want to add a guest to the beginning of the list, we would take index 0. Let's say, for example, we want to invite Larry Page. Next, let's use insert again, and we can add a value to the middle of our list. So that could be at position 1 or at index 2, for example. So let's say 2, and we want to re-invite Elon Musk, for example. And then finally we use the append method, which is going to add a value at the end, and that just takes one argument, one value that we add in here. So we can say, for example, we are going to invite Nikola Tesla, and then I believe we can print out a new set of invitation messages, one for each person in our list. So we can basically start with what we had before. And now if we think back, actually we can just print that out. If we print out our guest list here, we can now see that we have 1, 2, 3, 4, 5, 6 entries. So from 0 index to index 5. So we can add 3 more print statements here for the 3 additional guests. And of course we need to reference them. So at index 3, at index 4, and at index 5, like this. And now we are inviting all 6 people here to our guest list. Now finally, last exercise here, we just found out that our new dinner table won't arrive in time for the dinner, so we only have space for 2 guests. So we start from the program that we wrote so far, and we need to add a new line that prints a message saying that we can only invite 2 people for dinner. So let's do that here. This. Next, we can use the pop method to remove guests from the list one at a time until only 2 names remain in our list. Each time you pop a name from the list, print a message to that person letting them know you're sorry you can't invite them to dinner. Okay, so we can basically use our pop method, and we can store that return value in a new variable, let's say uninvited guest. And here from our guest list, we then use the pop method, and then we can print out a statement using an f string. Hello, uninvited guest. Unfortunately, we have to uninvite you. Alright, let's just take a quick look at that. So for example, here we have Nikola Tesla at the end of our list because we used append to add the value at the very end. And then we say, Nikola Tesla, unfortunately we have to uninvite you, and we should do the same thing for all of the guests except for 2 guests. So we have 6 values in here, so we need to do that 4 times. And we can just do the same thing again. We can define the variable uninvited guest. We can basically use the same name here and basically update the value, and then we pop off the value for the list of guests that has now 5 items in it because we removed 1. And then we print out that statement, and we do that 2 more times. So if we do that, we can see Nikola Tesla is uninvited, Jeff Bezos, Thomas Edison, and Elon Musk. And if at this point we just print out our guest list, we should only get 2 values back, which are Larry Page and Albert Einstein. Those are the only 2 guests that are still in our list. So we should print a message to each of the people who are still on our list, letting them know that they're still invited. So here we can basically do the same thing as before, but now we only do that for guest list at index 0 and guest list at index 1, because we only have 2 items left in our list. So Larry Page is invited for dinner, and also Albert Einstein, and the other users are not invited anymore. And then finally we use the del method to remove the last 2 names from the list so that we have an empty list. We can print our list to make sure that it's actually empty. So now we can finally go ahead and use del. We take our guest list and we want to remove the entry at position 1. So that should be Albert Einstein. And then finally we now have a list that has only 1 entry in it. which should be Larry Page, so we remove that as well. Now, if we finally print out our guest list, it should actually be an empty list. And we can see it's actually empty. We removed all the remaining errors, all the remaining values, so all the guests are uninvited basically, or have been removed from the guest lists. Now another very important aspect is organizing our lists. So sometimes our list will be created in an unpredictable order. For example, when we get some user input, when they enter some values that we request from them. And in order to properly work with our lists, we oftentimes need to structure our list in a way that we can work with it. So one very handy method that Python provides is the sort method, which we can use to sort a list of entries. So for instance, here we see a cars list, and we can use the sort method to actually sort our list of cars alphabetically and then to print out that result. And there are basically two ways of sorting a list, or two main ways of sorting a list. One is to permanently sort them using the sort method, and we'll also learn about a way to do that temporarily without changing the actual list. So let's head over to Sublime Text again, and now let's define our list of cars. So we have BMW in there, we have Audi, we have Toyota, and we also have Subaru. And now we can use the sort method to sort those values here, and by default they'll be sorted in alphabetical order. So if we now print out our list of cars, we can see that Audi is now the first entry because it's sorted alphabetically, followed by BMW, Subaru, and then Toyota. So we can see when we are using the sort method here, that actually changes our list permanently. So when we call sort on it, we can see that cars has been changed, so we are printing out the cars list, and the order has actually been changed, it has been modified. Here we have the result printed out in chronological order, or rather in alphabetical order, but we can change that around by passing an argument to sort. So we can pass reverse to it and then set that equal to true. Now if we print that out, you can see that we actually sorted it in reverse alphabetical order. So we start with Toyota, then Subaru, BMW, and finally Audi. Now if instead we don't want to change our list permanently but just temporarily, that's also possible. To do that, we would use a slightly different method. So instead of using sort, we would be using sorted. An example of that works as follows. We use sorted and we pass the list to it, for example cars. And if we print that out, we can see that now our list is sorted alphabetically. So Audi comes first, then BMW, and so on and so forth. But if we print out our original cars list up here, that is still intact, so that has not been changed. So sorted is a good option if we don't want to actually change our underlying list, but we, for example, just want to print out the sorted list and then leave the original list just the same way as it is. One important note here, if we print out a sorted, alphabetically sorted list of items, we actually need to differentiate whether an entry is uppercase or lowercase. There may be some unexpected returns otherwise. So for example, if we take, let's take Subaru here, and we capitalize that and we run that, or let's rather take Toyota. We are now printing that out in sorted order, but now we see that Audi is actually not at the beginning of the list, but we start with Subaru and then with Toyota. And the reason is that Python basically handles uppercase letters differently from lowercase letters. So ideally we would, for example, use the lower method or the upper method to actually have the same case, and then we can compare that directly using sort. So we can actually also reverse the order of entries in our list. So if we, for example, just take a look at cars at our list here, we print that out, and then we go ahead and we call reverse, which is another method on cars, and then print out cars again. we can now see that we changed the order of the entries. Now that doesn't change it based on the alphabetical order, but it just basically switches the position. So Subaru, which is the last entry, is now in first place, then Toyota second, after that Audi, and then BMW. So if you want to just rearrange our list, reverse is a very good way to accomplish that. So reverse actually changes the order of the list permanently, but of course we could just call reverse again just to get the original order back. So if we did this, we can see we get the original order of our items displayed here. We can find the length of the list, so the number of items in our list, by using the len method. So if we pass cars to it and then we print that out, for example, we can see that we have 4 items here, and if we were to add another item in here, we can see that we now get back 5 items. So that can be really handy, especially if we have a very long list and we quickly need to determine the number of entries. That is a really good option. So let's take a look at some exercises regarding this. So we should think of at least 5 places in the world that we'd like to visit, and then we should store the locations in a list and make sure that the list is not in alphabetical order. So let's do that. Let's create a new variable locations, which is going to be a list. Let's say we have Hawaii, we have Puerto Rico, for example. Let's say we have Australia in there, we have Japan, and let's say Iceland. So these are the options here that we added. Next, we should print our list in its original order. So we can go ahead and we call print on locations, so we printed out the original order. Next, we can use sorted to print our list in alphabetical order without modifying the actual list. And we should also show that our list is still in its original order by printing it out. So let's do that. Let's first use our print method here, and then we can use sorted and pass locations to it. So now we sorted our list. Australia is now first, Hawaii second, Iceland, Japan, Puerto Rico after that. And now this only temporarily changed the order. So if we go ahead and we print location again, we can see that we still have the original order here of our items in our list. So that has not been modified. So next we should use the reverse method to change the order of our list, and then print the list to show that its order has actually changed. So to do that, we can use our locations list and call reverse on it. And now if we print locations one more time, we can see that Iceland, which was the last entry in our list, is now the first one, followed by Japan, and at the very end, at the beginning of the original list was Hawaii, which is now the last entry. So they actually changed the locations list here. Next, we should use the reverse method again to change the order of our list, and then print the list to show that it's back to the original order. So if we use reverse again, then this is going to revert the item order again, and therefore we get back our original order. So let's check that. So here we see Hawaii, Puerto Rico, Australia, Japan, and Iceland, which is identical to the original order. So calling reverse twice on a list basically reverts it back to the original order. Next, let's use sort to change our list so it's stored in alphabetical order, and then print the list to show that the order has been changed permanently. So to do that, let's take locations and call sort on it, and let's print out locations. And now we can see that actually the order has been changed permanently because we print out locations and sort has actually changed the order here. So that's the difference between sort and sorted. After we sorted locations here and we printed it out, that was actually reverted back, which is the third line here. So that didn't change the locations list itself, but sort actually does. And finally, let's use sort to change our list so it's stored in reverse alphabetical order. And then we should print out the list to show that its order has been changed. So to do that, we can call sort again on locations, and here we pass the argument reverse equals true to it, and then we can print out our locations list, and now we can see the order has been changed. So Puerto Rico, Japan, Iceland, Hawaii, Australia, so it's now sorted in reverse alphabetical order. Next we should take our dinner list, working with one of the programs that we worked on before, and use len method to print a message indicating the number of people that we are inviting to dinner. So let's think back. We had here our guest list, and we had, for example, Albert Einstein, Elon Musk, Thomas Edison in that list. Now if we call print and we pass guest list to it with the len method here, we actually get the number of entries, so 3. So if we want to print a message here, we could write something like this. We use our print f method. We can say there are len guest list guests invited to the party. So here it says there are 3 guests invited to the party, and those are exactly those 3 entries that we have stored in the guest list. So len is really helpful to identify how many entries we actually have in our list. And then finally, we should think of something that we could store on a list. For example, list of mountains, rivers, countries, cities, etc. And then we should write a program that creates a list containing these items and then use as many functions as possible introduced in this chapter at least once. So let's just create a list items, and we can store some values in it. So let's say mountains, apple, computer, for example. And then of course we could go ahead, we could reference a value here and, for example, change it. So mountains could be changed to something else, example to flower. And then if we print items, we can see that this has been updated, so mountains has been replaced by flower. We can of course also go ahead and append an item, so we can say items append sun, for example. So that will be added at the end of the list. If we want to add something not to the end of the list but to a different position, we could use insert, for example, and add a value to the beginning of the list, for example rock. So now we added that in here. We could of course also delete items, so we can say delete the value at position 0. So now we can see we basically removed that, so we inserted rock here but we removed the value, so it has been removed from that list. We can of course also say items remove, and then let's remove the value with the name apple. So now apple has been removed from the list. We could go ahead and we say items reverse to change the order. So that should flip it around like this. So these are some of the ways that we could accomplish that. And of course at the end, for example, we could say we also want to print out the number of items that are now in our items list. So here we see we now have 3 items in our list. One important aspect to keep in mind is to not index or not reference any values outside of our list. So we should always make sure that when we use an index, that we refer to an index that's actually in the list. So let's take a look at an example. If we, for example, take a look at our motorcycles list, and we have Honda, for example, in there, we have Yamaha, and we have Suzuki. Then, of course, we can go ahead and we can, for example, reference index, the value at index 0, this, which would be Honda, the value at index 2, for example, which would be the 3rd entry here, Suzuki. But if we try to reference, say, a value at index 3, which does not exist, then we get an error message here. And if we take a closer look here at the bottom, we can see we get an index error. List index out of range. So that basically says that Python is now trying to take a look at a value that's at position at index 3, which is actually not in the list. So that's, we are basically off by 1 in this case, and this is why we get this error message here. So in such a scenario, if you want to reference the last value, it can be safer to instead use the separate syntax like this to reference the very last entry in the list by using -1. And that's a lot safer and definitely reduces the risk of such an error happening. It can still happen, so if we have an empty list, for example, like this, and then we try to get the last element here, since that list is empty, we'll then also get an error message in this case. So if we actually get an index error and we can't figure out why that's happening, it can really help to print out the length of our list. So using len, that can be really helpful to narrow down what's actually going wrong, and if we maybe refer to a value that's actually not in our list, that we use an index that's larger than actually our list itself. So there's one final exercise. So to cause an intentional error, so if we haven't already received an index in one of our programs yet, then we should try to make that happen. So we should change our index in one of our programs to produce an index error. So we already saw that here, but of course one additional way to have such an error happen, so this would be the correct case, but we could also use the negative indexing from the end of the list, and if we try to, for example, reference the second to last value and we only have, let's say, one entry in here, then we would also get such an index error. We learned what lists are, how we can access elements of a list, and also how we can add or remove items to a list. We also learned about how we can organize a list. In the next video, we're going to learn about some more efficient ways of working with lists, for example by looping through them. See you guys in the next video.